into the seamless segue into the theme of the current exhibition that's on in Science Gallery. Homesick Post-Domestic Bliss is the current exhibition. If you haven't seen it, maybe you might check it out. It's running until the 19th of July. And in this exhibition, we are challenged with the idea of what is home, what it means to us, and what it might mean in the future. And we're very lucky to have Ariel Waldman with us tonight because she's going to lead us on an exploration of what home means to us and our place in the universe. She's probably the most qualified person in the world to do that. Before we formally start proceedings, I should just make a note about the format of tonight's event. So Ariel's going to give a talk, and then afterwards we're going to have a Q&A. We're going to use Twitter to facilitate the discussion. So you'll see behind us, we have some useful information. On Twitter, you can ask us some questions using the hashtag @HomeInTheUniverse, which took me so long to type earlier that I thought, I'll abbreviate it to another one just in case, which is hashtag AHITU, which I spelled wrong on Twitter, and then someone very kindly corrected. Spelling is difficult. So yeah, that's all the information you need. That's Ariel and myself and Science Gallery. So when Ariel's speaking, if you have any questions, all those burning questions about our place in the universe, feel free to tweet them to us, and we'll look through them, and then after the talk, we can try and answer them. Also, if you don't have Twitter, don't worry. You can still utilize your hands, and we can deal with questions like that too. Okay, so I think that makes sense to everyone? We're good with that? Okay, so without further ado, I'm going to introduce our speaker. Normally, with a formal introduction, you list all the achievements of the speaker, but I'm not going to do that. One, because we'd be here all night, but two, because I think when Ariel explains her journey, it just is a much more appealing idea than me trying to condense it into a couple of lines. So I'm just going to start by saying that Ariel investigates how to ways to make science and space more collaborative, more accessible, and in doing so, she's got to the point where she is now the global leader at making science and space more inclusive. So we're very lucky to have Ariel here with us tonight, and I'd like to just offer a warm welcome to Ariel. So, Ariel Waldman.
Thank you, and I'm so excited to be here. So this is my second trip to Dublin. On my first trip to Dublin, I visited the Science Gallery, and I instantly was like, if I lived in Dublin, I'd be here hanging out all the time. It's just geeky awesome for so many reasons. So one of the slides I wanted actually to begin with on this whole thing about our home in the universe is this image here. And this is an illustration of our galaxy, the Milky Way galaxy. And if you can see, there's a little tiny blue speck up there. That tiny blue speck represents the 200 light years in diameter that surrounds the Earth. And that 200 light years in diameter is essentially the dot in which any radio waves that have come from Earth could possibly be detected by alien civilizations. And so when thinking about our home in the universe, as a geek, I guess I really like thinking about how throughout our galaxy there might be all these little dots sprinkled throughout, and we all might be trying to communicate with each other or just sending signals out, and we might all be in our own little bubbles and unable to actually see each other. And this is because, at least when it comes to radio waves, at around 100 light years away, the radio waves become indistinguishable from noise. So I'm Ariel Waldman. That little bubble is where you can find me. That's my home in the universe. Another image I wanted to share with you all is this one, and I've really fallen in love with this image. This is something that looks like it's very far away in outer space. It's nebulous and artistic and almost chaotic in a sense, but what we're looking at here is our own home. This is the Milky Way galaxy, and this is an actual image of the Milky Way galaxy. And what I find fascinating about this is that this is not how we usually picture our own galaxy looking like. When we usually think about what the Milky Way galaxy looks like, it looks something more like this, sort of a quaint spiral galaxy, which our galaxy is. But when we're able to actually see it, and actually peer past a lot of the space dust and space gas and look into the center of our own galaxy, it looks like this. And so why this image is so important to me is because it's really, for the first time, one of the images where we're able to actually see our own home. And this is because the space dust and space gas that permeates throughout our entire galaxy usually blocks our view of being able to actually take pictures of our own home. And so that picture was actually taken by one of my favorite space probes, the Spitzer Space Telescope. And the Spitzer Space Telescope uses infrared to peer past all the space dust and space gas out there and actually get that gorgeous image of our Milky Way galaxy. And those pictures are very much taken from the viewpoint of our home because the Spitzer Space Telescope actually orbits around the sun. It kind of trails behind the Earth. So you can't see Earth in any of those images because it's sort of taken from the vantage point of Earth. So here's just a few more of these images, and I just think they're absolutely beautiful, and I really like how it changes what we think our home looks like. Just these really fascinating, beautiful images. I really, I'm kind of at a loss for words for them, honestly, because I just find them so fascinating. So, also interesting is that this was a depiction of what our home, the Milky Way galaxy, looked like in 1785. This was a depiction made by William Herschel, and what this is actually showing is this was his best drawing of the shape of the Milky Way galaxy in 1785, and this was based off of a bunch of star observations that he had made. And if you can see in the center up there, there's a little, it's hard to make out, but there's a little bold star in the center, and that's where he thought Earth was. It was a bit off. We now know, we're not in the center of our own galaxy, which is quite good because it's very chaotic in the center of our own galaxy, and we'd be dead. Kind of a good thing. We now know we're more like in the suburbs of our galaxy. Also fascinating to me is that it hasn't even been 100 years since we thought that there were any other galaxies in the universe at all. 100 years ago, we thought the entire universe was the Milky Way galaxy, that maybe there were some nebulas and some other stuff at the periphery, but pretty much the Milky Way galaxy was the only galaxy in the entire universe. It wasn't until 1924 that Edwin Hubble spent a lot of time looking out into the sky at actually a blob. This blob was this, and determined that this blob, that at the time was called the Andromeda Nebula, was in fact a galaxy unto itself, and that it was the Andromeda Galaxy, and that we are not the only galaxy in our universe. Now, of course, we know there are, as is often famously said, billions and billions of galaxies out there. I just find it interesting that it hasn't even been 100 years since we've known that. Also interesting because in the year 964, about 1,000 years before that, was the very first known depiction of the Andromeda Galaxy, which you can see here. Essentially, a Persian astronomer depicted this and said that described the Andromeda Galaxy as essentially being a cloud at the mouth of a fish, the fish being an Arabic constellation, and that little cloud there with the little A for the Andromeda Galaxy. So it only really took us about 1,000 years or so to go from the first known depiction of the Andromeda Galaxy to determining that it was a galaxy unto itself and that there are many galaxies in our own universe. Also interesting because if any of you are geeks, that you've spent a lot of time looking at the very same galaxy that both Hubble and Persian astronomers have. Mac OS X famously shipped with this image of the Andromeda Galaxy as its default desktop wallpaper. So I like the fact that we might have spent as much time looking at this galaxy as Edwin Hubble did, which is kind of cool. So I like thinking about our home in the universe, not only in terms of space, but also just to briefly touch on also our home in terms of time. Space and time are kind of one, and it's important to know that we're not only this small little dot within the universe in terms of space, but we are also this small little dot in the universe in terms of time. This is a chart that I borrowed from Jill Tarter, and just showing sort of even our place in time is very, very tiny in terms of just millions and billions of years. And it's important to sort of, I guess, understand that we exist both in space and time in sort of a very tiny way. So our home, in a sense, is very tiny. Also, in a sense, this relates to my own experience with space exploration, because my own time in space exploration has been very small. I have not always been working in science and space exploration. In fact, I went to school for graphic design. I went to art school. I worked at an ad agency for a number of years. And it wasn't until 2008 that I was watching this great documentary called When We Left Earth. If you haven't seen this documentary, I really recommend it. I think you can find it on iTunes. And it's this documentary about NASA during the early days and how they were trying to figure out how to do space exploration and how to send people into space. And I found this documentary so incredibly inspiring that I decided to send someone at NASA an email saying that I was a huge fan of what they were doing, and if they ever needed someone like me, someone completely without a science background, that I was around. It was very geeky. I didn't expect to get a reply back, but serendipitously, I was able to get a job at NASA from that email, and it completely changed my life, as you can imagine. So I wanted to actually share with you a clip from this documentary that sort of explains why I found it so inspiring, documenting when NASA was trying to figure out all these different rockets. They were rockets without any humans on them, but they were rockets that they were trying to figure out that could one day send humans into space.
To beat the Soviets, NASA must launch a man into Earth orbit. Only rockets can go fast enough.
We knew nothing about rocketry, we knew nothing about spacecraft, we knew nothing about orbits.
I saw a lot of rockets launched. I'd say that somewhere between 30 and 40% of them failed. A lot of them came up off the pad and went the opposite direction. Some of them got halfway off the pad and blew up. Some of them got to 10,000 feet and turned the other way and blew up.
The whole thing crumbled and blew up. It looked like an atomic bomb went off almost over our heads. We got a big kick out of watching the Mercury astronauts. It was great looking at their eyes. We're looking at this thing and looking at each other and deciding we want to go back and talk to the engineers a little more before we go further.
And so that's why I love so much about this documentary. I always show this. It reminded me of this image here. That, it was something where I realized, NASA didn't necessarily know what they were doing. Like, they didn't know space exploration. They were figuring it out as they went along. And so when I was watching this documentary, I was saying to myself, I don't know anything about space exploration. I want to work at NASA. That sounds amazing. and so I was lucky, and I ended up getting this job at NASA, and it completely changed my viewpoint. It changed my viewpoint from everyone at NASA being essentially rocket scientists to being more space hackers. And it was a really, I guess, important thing and changed my perspective in such a way because, working at NASA for me was like getting paid to go to school. I got to learn about dark matter and robotics and all these different things, but one of the most important things that I ended up learning while I was at NASA was that I didn't need to work at NASA in order to explore space. And so I left. And I created spacehack.org, which is a directory of ways to participate in space exploration. So this is things people can do with or without formal science backgrounds to actively contribute to space exploration and scientific discovery. Since creating SpaceHack, I've had a fairly interesting career, I guess. I recently was on a National Academy of Sciences committee about the future of human spaceflight, which, similar to working at NASA, when I showed up for this, I had no idea how I got there. It was the National Academies are this very prestigious thing, and if you work in anything even remotely connected to the sciences in the U.S., you're completely aware of them. Literally, when they emailed me and asked me to be on a committee, I had never heard of them before, and I almost didn't respond to their email. Now I know that that sounds ridiculous to a lot of scientists that I could possibly do that, but it was a really fascinating experience. But I probably got, I guess, a little bit saturated with human spaceflight stuff, so I wanted to do something also related to the more robotic side of spaceflight. And so I recently launched and created a site called Space Probes, the URL being spaceprob.es. And this is essentially a catalog of all the active human-made machines that are at the moon and beyond. And it catalogs all these different space probes that we've sent out into the solar system and also their current distance from Earth. So some of the projects that are on spacehack.org that are interesting are projects like the Austrian Space Forum. And the Austrian Space Forum is an interesting organization because they try and generate as much research as they can about how we could one day go to Mars. And they're trying to generate this body of research for whoever decides, whoever accomplishes going to Mars. They want to be able to build up research about spacesuits and rovers and all different types of things. And the thing that makes them interesting is that they take on volunteers from all different backgrounds to sort of help generate research, and in a lot of different areas. So they might need lawyers as much as they need writers, as much as they need web developers or designers, what have you. They essentially are open to having help from all different types of fields to come together to kind of create a body of research that could help people one day go to Mars. So one of the projects that they've done in the past is one where this image here, where they're essentially digging in an ice cave in Austria to try and figure out how they could find signs of life in an ice cave that might be analogous to Mars. Also, I think later this year, they've got a Mars analog research program that's coming up as well. That's really fascinating. So the thing that's kind of cool about this is there's a lot of work happening now in sort of this area of how we might be able to find microbial life on other planets. A lot of this work falls under the discipline of astrobiology, essentially studying how life is here on Earth and the extremes of life here on Earth so that we can better understand how life could exist on other planets. So an interesting project that I recently came across was a project from Cornell University that created sort of a Pantone palette of all the microbial life that exists here on Earth, on the surfaces of the Earth. So on the surfaces of deserts and the surfaces of oyster ponds and all different places. And they essentially created this alien, what I call an alien Pantone palette. Essentially all the colors and different forms of microbial life that exist on the surface of the Earth. And the reason why they did this is because one day we're going to be able to image the surface of exoplanets. And if we see different colors showing up on the surface of exoplanets, we need to be able to at least have a guess as to what could be causing those colors if there is life on those planets. And so this is sort of like this is why I call it an alien Pantone palette. You could sort of hold it up against a planet that you're looking at one day and sort of be like, well, maybe it's these microbes from an oyster pond that are on an exoplanet or something. I find it really fascinating, I guess, because astrobiology to me is kind of an art because you're kind of using Earth as a palette to paint with and saying like, okay, if I've got all these different ingredients on Earth, if I've got all these different ingredients in our home, how could I mash those together to paint different things, or what sorts of things might show up on other planets? Another interesting project actually out of Cornell University is one that looked into life as we don't know it. And this is something I get asked about quite often. People are like, well, yeah, but like, what if life looks like something completely different? Which is, of course, very difficult to do because it's not exactly evidence-based, but we can at least try, again, painting with different materials to try and see what we can get. And so a group of scientists actually painted with the materials of Titan, which is this moon here. It's the moon of Saturn. And Titan is a really interesting moon because it's got lakes of methane and ethane on it. And it's got a thick atmosphere as well. And so what happened was actually a group of astronomers teamed up with a group of chemical engineers, and sort of by using the materials that were present on Titan, they sort of created a template for a life form that could possibly exist on Titan. They created essentially this, which is a cell membrane that's based on nitrogen. Because I'm not a chemical engineer, I can't go into too much detail about this, but I found it really fascinating that they essentially said, okay, if our color palette is not our home, if our color palette is Titan, what could possibly exist on there? What types of life should we maybe consider searching for, even though it doesn't match anything here on Earth? Another cool project to come out of spacehack.org is Galaxy Zoo Radio, which is a project in which you can go and you can actually search for black holes, and you could actually possibly discover a black hole that no one's discovered before, for which you would actually get your name on a scientific paper for, which would be really cool. Also really cool just because black holes are really cool. Like, black holes are these things that actually I get very emo about, because people give them a bad reputation. They're these, they're seen as these things that destroy entire planets or entire stars, and they're destructive, and they're, these mean forces of nature in a sense, which is true, but they kind of also do the opposite. They're also these incredibly creative forces of nature. While they gobble up all of these planets and stars and all these things, they oftentimes take in more than they can chew. And when they take in more than they can chew, they vomit it back out into the universe violently in the form of mixed up space dust and space gas. And that mixed up space dust and space gas can actually go on to create future planets, future stars, possibly might even be a very important part of creating galaxies. There's a lot of research still being done about this. So while we can't actually image a black hole because, as many of you probably know, even light itself can't escape from a black hole, we can image a black hole's vomit. So this galaxy, this is M83, not the band, but the galaxy M83. And inside that circle there is essentially a black hole's vomit, which is lovely. This is an image of this process taking place, even a better image of it. The black hole essentially, taking in all this stuff and then vomiting it back out into the universe. And, to me, when I look at black holes, to me, they're sort of like the supermassive hackers of the universe. They kind of sample all the material around them, mash it up, and spit it back out to create derivative works, in a sense. I think it's, I, as a space geek, I like all the things that are sort of at the edge of our knowledge. Also things that, like the fact that 95% of everything in our home, our wider home, is invisible. And when I say 95% of everything is invisible, I really mean 95% of everything. This is a pie chart of all of the energy and matter in the universe. And as you can see, less than 5% makes up all the ordinary matter. Dark matter and dark energy are things that we can't see. And all the ordinary matter in the universe means like all the planets you could ever see, all the stars you could ever see, all of that makes up less than 5%. And I think it's interesting to sort of question and think about where all that ordinary matter comes from. A lot of you might be familiar, essentially, we're carved out of supernovas. Supernovas are these incredibly beautiful things that essentially create everything around us, with maybe the exception of hydrogen, I guess. So supernovas are when stars of a sufficient size essentially run out of fuel, and then they collapse in on themselves, and when they're doing that, they're fusing heavier and heavier elements. And so supernovas are very much to thank, I guess, for our home. And so you might know, depending on your age in this group, Carl Sagan talking about how you're made of star stuff. But if you want to be really geeky about it or knock your friend down a little bit, you could say you're only 93% star stuff. And that's by weight. The rest of you is hydrogen. Just something interesting to think about, since hydrogen technically existed before supernovas did. So, an interesting project is how we detect sort of the output of supernovas here on Earth. This is an image of the Cube Observatory, which is in Antarctica. And the Cube Observatory looks for neutrinos, which are neutral particles that sort of get spit out from supernovas and a bunch of other places, even on Earth. But supernovas also produce them. And how the Cube Observatory looks for neutrinos is it's essentially got a cubic kilometer of ice, clear ice in Antarctica. And embedded in this cubic kilometer of ice is about 5,000 sensors, optical sensors. And what these optical sensors look for are blue flashes of light. And why this is because as neutrinos go through the ice, they actually produce blue flashes of light. And so we can actually detect a neutrino coming in and sort of measure its energy and its direction and tell if it may come from a supernova or not. So this is sort of an artist's depiction of all these optical sensors that are embedded into this. What I find interesting about this is that essentially it ends up creating sort of a 3D scan of these neutrinos that are coming to us on Earth from supernovas. And while this is fascinating, I also think it's fascinating to think about how we could 3D scan supernovas themselves. We get all these beautiful images of supernovas, which is great, but we don't really get a sense of their depth very well. And so we can't exactly take a Kinect and hold it up to the sky and get sort of a 3D scan of supernovas that way. And we can't necessarily shrink a supernova down, bring it here on Earth, and put it through an MRI machine and get a scan of it that way. But that's somewhat like what some hackers did, science hackers, I guess, at Harvard. They essentially took this software, which is open source software called 3D Slicer, which creates these 3D maps of brain scans from MRIs. And I took this software, and how this usually gets put is they get all these scans, they put it into the software, and then they get these great 3D fly-throughs of brains. But a group at Harvard actually wanted to know, what if instead of scanning brains, we scanned a supernova? So they actually took imagery and data from Cassiopeia A, which is this supernova here, and they fed it through this software, and they got this really lovely scan of a supernova. This is actually, believe it or not, the very first 3D fly-through of a supernova remnant that was ever created. There's now even better ones that have been created. But this was really great because this was essentially the medicine department teaming up with the astrophysics department at Harvard to create these great things. And this is something that a lot of my work focuses on, is getting sort of multidisciplinary collaboration and getting sort of these serendipitous and clever solutions created when you're taking people from different disciplines and putting them together. So another interesting project I've had the honor, I guess, of working on is NASA Innovative Advanced Concepts, also known as NIAC. And NIAC is, I'm very biased, but I think it's the coolest program at NASA. It's essentially the program that funds all the more sci-fi, out there, futuristic yet credible research that could possibly transform future space missions. And the thing that's really cool about NIAC is that actually anyone can propose to NIAC, and they have a submission process. I think they open up submissions every October or so. And anyone can submit, but it's all about being able to produce credible research for sort of the more out there ideas. So some of the things to have come out of NIAC have been concepts like the comet hitchhiker, which is really fascinating because when I first heard about the comet hitchhiker, I thought, that's not interesting. We've got Rosetta, and Rosetta's amazing. This is this amazing spacecraft that's at a comet, and the Philae lander has landed on it. Why do we need another spacecraft at a comet? Not that I would complain about that, but I just didn't know what was new here. But the comet hitchhiker isn't about having a space probe go land on a comet. The comet hitchhiker is about using comets as a propulsion system for space probes, which is utterly fascinating to me. The concept is to have a space probe go up to the comet, harpoon into it, and reel out an incredibly, incredibly long tether, and then harvest the kinetic energy of that comet to then explore the solar system twice as fast as any of our current space probes can. I just love the idea of using, I guess, natural resources as propulsion in this sense. So with the comet hitchhiker concept, they estimate that it's taken the New Horizons probe, which is currently on its way to Pluto. It's taken it nearly 10 years to get to Pluto, but with this sort of concept, they estimate that they could go to Pluto in 5.5 years. So you can start to see how that could actually change how we approach space missions and budgetary issues and all sorts of stuff like that. Another cool concept, I'll see if I can do a good job of explaining this, is essentially a concept to navigate a rover around only the sunny areas of the moon. So this is almost like a video game that you're seeing here, where the rover's going like, okay, don't touch the shadows, like the shadows are lava, right? Like, don't touch them. And what this team did is they took imagery of essentially the solar phases on the moon, and then they did sort of some computer vision work and were able to calculate these sort of routes that rovers could take on the moon so that they could avoid shadows. Why this is important is because a lot of times it's cheaper or easier to send up rovers to the moon that are only solar powered, but that means that a lot of times they have to turn off for long periods of time and can't conduct as much science because they're not getting as much sunlight as they need. So that's sort of what this concept was. Another cool one was a concept to send a submarine to the lakes of Titan to explore them and find out different sort of what materials are there and search for all sorts of different things. It's a quite fun concept, I guess, just to think about being able to send a submarine to a lake somewhere else in our solar system. This project was another interesting one where they wanted to essentially create 3D maps of lunar caves. So on the moon, there's all these caves, and you can't necessarily see entirely inside them. So they're sort of permanently shadowed, and you can't see everything about them. So this was a concept to essentially take technology that was developed at MIT and apply it to a spacecraft. And the technology is a camera that sends out photons. And these photons bounce off of all these different walls, and so you can actually see behind corners, because as these photons are bouncing off all these different walls, they bounce back into the camera, and the camera, which is very specialized, can actually tell the time of when these different photons bounce back into the camera, and thus it can draw a map. So in this image here, the lower right image is what was drawn essentially based off of that procedure happening. So you can start to actually see behind corners and see behind walls, in a sense. And so this is sort of what lunar caves look like. So as I mentioned, anyone can apply to NIAC. It's really just about having ideas that can transform future space missions, whether it's coming at it from a biology angle or the human spaceflight angle or the robotic angle, doing space science or not doing space science, sort of just all these different things, just things that could be applied to future space missions. And it's just a really fascinating project to be involved in. So what I love so much, I guess, about space exploration and all these projects and science fiction, for that matter, is how it's all about exploring the unknown. And I think that's something that is very center to actually our idea of home, as difficult as it is to sort of grapple with that. When I look at images like these of our home and sort of am fed new definitions of what our home here means in space and time. I think that's the thing that's really fascinating, is that our concept of home, when we look at it from the viewpoint of space-time, is constantly changing as we're getting more information and conducting more science. And so I like this concept of home as being more of a nebulous thing. And a favorite quote of mine that sort of gets to the center of it from John Peel is, "At the heart of anything good, there should be a kernel of something undefinable. And if you can define it or claim to be able to define it, then in a sense, you've missed the point." And so to me, that's really the concept of our home in the universe. Thank you.
Thank you, Ariel. Wonderful. And we now have some time for some questions. So there's a couple of questions coming in on Twitter, which we'll get through. So remember the hashtags you can use to have your question heard. I'm going to start with some questions. If I forget to take any questions from the audience subsequently, because I just get too involved in my own questions, you can cough loudly and I'll move on. Ariel, the first thing I want to ask you about was Nyack, because I think it is, you're definitely right, it's the coolest panel committee in NASA. What I want to know is how does it work in practice? Because like say you go into the room with all these people whose challenge it is to come up with these innovative advanced concepts and to figure out what they can do. Like if someone says something, proposes something, and then someone else says, that's crazy, and someone else says, that's why we're here. Like what is a process? How can it function?
Yeah, so the way it works is actually, every October or so they open, it's an open call, and they ask people, actually, it's easy enough. The first step is to submit a white paper, like a 3-page white paper, like super lightweight, on what your concept is, your execution plan, like how you would prototype it, and all that. And that gets submitted into NIAC. And so NIAC actually has a panel of peer reviewers who represent, a bunch of different angles. And that process, actually, I can't tell you much about because they actually don't let me anywhere near it. I'm on the external council. And so why I'm able to actually, recommend and talk people into submitting to NIAC is because I have no say in what gets chosen, which is, which I'm sad that I don't get to know more, but each year they select, a good handful of different concepts, and they really do range all these different, and some of them are way more out there than others. Like some of them are like, they're game changing, but game changing on a scientist level, like, making a telescope be upgraded to, something where it's got like a better lens in some way, like something where it's not too crazy. But there's other ones that are like, they've literally funded ones that are about human hibernation on the way to Mars, how to do that.
Awesome.
Like, yeah. So it's something that I think is really cool, and I think is also cool from the sense that you don't have to be a space scientist necessarily to submit to it. You could be doing, interesting research or interested in different things, and because they've had things that are about like 3D printing biology on Mars and things that like where people might not actually be involved in space whatsoever, but might want to take something that they're doing and say, oh, actually this could be really useful on a human mission to Mars or for a robotic spacecraft or something like that. So you've had particle physicists, and like the Titan submarine I love because you're getting like oceanographers doing space exploration stuff, which is pretty cool.
So one of the debates that comes up with those type of concepts is it's often manned missions or it's robotic missions. And just one of the questions from the audience is should we send robotic rovers instead of humans, in your opinion, because robots are much cheaper?
To me, it's definitely not an either or. It's a both. I think there's a lot to be achieved as long as it's seen as sort of a more cybernetic system where you've got humans and robots sort of interacting with one another. And that's not me just like being nice and not picking a side. I honestly think that's a really efficient way to do space exploration, so long as you're looking at what do robots do best, what do humans do best, and really making sure you utilize them in an efficient way on both sides of it. So obviously you're not going to be sending a human to Pluto or anything like that. We don't have that technology, but sending humans to the moon and working alongside robots so that they can both accomplish as much as possible, I think that's really the way forward. And I think when it comes to humans, even though it's very expensive, you evaluate the expense, you evaluate the cost of life that might exist, and you sort of weigh that with what you're trying to achieve, and you don't take that lightly. So I think as long as it's a thoughtful decision, that it should be both. Okay.
Well, thanks for the question there. So the great thing about Twitter is that you can submit whatever you like, and we'll ask your question anonymously. So thanks very much to Jeffrey in the front row for that last question. In terms of space probes in general, do you have a favorite?
I have many favorites, but I mean, my go-to is usually Voyager 1 because it's traveled the farthest, and I think that's pretty awesome. But I also have I love the Spitzer Space Telescope, which I talked about, because it was able to take these images of our own galaxy for the first time. Another one I love, which I think now is defunct now, is WMAP, which took pictures of essentially our universe when it was a baby. It was taking pictures of the universe when it was like 300,000, 500,000 something in that range years old, and being able to get pictures like that of what our universe looked like so long ago is fascinating. I told, the Mohawk guy at NASA from the Mars missions, I told him what my favorite space probes were, and I explained it was like, oh yeah, I like Spitzer and WMAP and Voyager 1. He's like,
where's Curiosity?
That, and he was like, you're a space hipster. he's like, you like all these unknown space probes or something like, yeah.
Yeah. Well, since he did date an Irish girl for a while, so he has that to deal with. Okay, we have another very intelligent question from the audience. Question for Ariel. I hear you run an amazing event called Science Hack Day. Wouldn't it be great if there was one in Dublin? Winky face.
Is that from David?
David McKeown.
Oh, yeah. Who is that? Yeah.
Who is that guy?
He's definitely not the organizer of Science Hack Day Dublin.
And definitely not the person who taught me how to wear a suit. Thank you, David.
So Science Hack Day, which I didn't talk about, but is actually kind of key to some of the concepts at least. So Science Hack Day is a weekend event in which scientists, designers, developers, and all different types of people get together in the same physical space to sort of see what they can rapidly prototype with science in 24 consecutive hours. It's kind of openly chaotic. And so anyone can organize a Science Hack Day. They happen all over the world. We're just about to hit 20 countries. And one of those countries is Ireland and in Dublin. And actually the next Science Hack Day in Dublin is, I believe, November. And it's just a great event because you get those weird crossovers. You get those crossovers of like people in medicine working with people from astrophysics, and you get lawyers collaborating with microbiologists, and you get people from completely different disciplines inside and outside of science. You don't need any experience in science or hacking to attend. Certainly, I didn't have any experience in science or hacking. And it's really just about getting excited and making things with science, really. So it's a good event. So if you want to mark your calendars for the Dublin one, I think the website is sciencehackdaydublin.com.
I'm sure we'll have a tweet to correct us if that's not right. Yeah. The interdisciplinarity is of course key, and it's something that we take very seriously, especially in Science Gallery, because we like to bring as many different disciplines together as possible. Some of the audience wants to know, what else could scientists learn from working with designers, do you think?
A lot, a whole lot.
How to communicate.
The thing that's been fascinating actually through Science Hack Day is, I come across a lot of scientists and researchers who are extremely skeptical, especially in academia. There's a huge pressure to not waste your time on things, to stay really, really focused on what's right in front of you. And yet, the scientists who participate in Science Hack Day, the ones that I've convinced and sort of dragged to Science Hack Day in a sense, have sort of come out the other side like just completely in awe, because a lot of them feel that their work is so complex and it's taken them so many years to understand it, that how could they possibly collaborate with anyone else and like actually produce anything? And they're able to come out the other side of Science Hack Day having produced either visualizations or interfaces or new ways of like thinking about things and conceptualizing their work that actually then go on to feed back directly into their work, whether or not they came to Science Hack Day, wanting to be efficient. It's been great, and so I think it's a lot of my work focuses on getting people without formal science backgrounds to contribute to science, but equally it's about getting scientists to realize how they can do multidisciplinary collaboration and how it's actually a benefit, and how even though they might work in a very complex subject area and they can't expect people to know everything they know, that people can actually surprise them by having a different perspective on something. A lot of times you have those serendipitous moments, clever things are created, new ways of doing things are created, and a lot of it's because they're stepping out of what they're exposed to every day and being exposed to completely new ways of accomplishing things.
And one of the early examples of people from different disciplines collaborating together on a space project was the Voyager Golden Record, which is now coming up to 2 years' time. I think it's its 40th anniversary. So Voyager, being the spacecraft that's furthest from us, is just at the edge of the solar system, and it was innovative in its time that it could. They allowed people to be a little bit thinking outside the box and making a record that they could put on this space probe in case an intelligent civilization would one day receive it, and then they would have all this information about Earth. And I think that was probably one of the first times that scientists had to work with artists and designers and try and think, how do we capture what home means to us so that someone else can interpret it. So I guess if we were to do Voyager again today, if we were to do the golden record today in 2015, not 1977, how would you describe home to another potential sentient being?
That's actually a really fascinating question. You don't know this, but so there was a Science Hack Day in Washington, D.C. A few weeks ago, and actually a team took on pretty much exactly that challenge of like, if we're going to do an updated golden record, what's going to be on it? And I can tell you, those were some really heated debates. Like, people got really, because, here's the thing, it's like Voyager 1, while it's great, and we want to talk about how great it is, it wasn't inclusive. It was, a group of scientists deciding this is what humanity is, and then sending it out there and sort of representing kind of their viewpoint of home, which, I think rightfully so, a lot of people can be offended by. And so at the Science Hack Day in Washington, D.C., a group got together, a diverse group of people from different disciplines got together, and there were some real arguments about what represented humanity and why even send it out in the first place and all this stuff. What they ended up doing a project on, and I'm not to say that this is the pinnacle answer, but I thought it was a pretty interesting one. It was, they essentially threw away the concept of icons and, drawing our place in space and saying this is, what a human looks like. They wanted to actually take our a piece of like our DNA or a piece of our microbiome or what have you. They wanted to take our biology and just put that on a chip on a spacecraft and send that out there. And that was it, like no explanation, no nothing, just that. So a lot of what they were working on was like, how do you possibly protect biology in such a way on a spacecraft, which is, that's a pretty difficult, it's difficult enough to send humans into space, but to send a little piece of, our biological makeup into space and have it go as far as Voyager without being completely irradiated, is quite a challenge. So that's what they looked into. Another interesting aspect of this is that there's someone, so there's the SETI Institute in California, which is the Search for Extraterrestrial Intelligence Institute. And there's someone that works there that has the coolest job title that I've ever come across. It's Director of Interstellar Message Composition.
Solid.
Seriously, ever since I've heard of that job title, I've met cool people at NASA. I've met astronauts. Director of Interstellar Message Communication or Composition is the coolest job title I've come across. And his whole job is sort of looking into the philosophy and theorizing on what different aspects of humanity to look into and what sorts of things can communicate even like the math of our universe through music and through doing research into how dolphins communicate through some, I forget which species, but there's some species that essentially communicates through pictograms, through blowing through their mouth, and they create kind of these things that are actually pictograms of a language. Really fascinating stuff that I wish I could say more about, but I've really just know it at a headline level. But actually looking out and researching and spending a lifetime researching how to do interstellar message composition, I think is fascinating. And it warms my heart that there is someone on Earth that at least that's their full-time job. And so he's a really fascinating person to look up. Because
it's a challenging idea even in the first place, because for Voyager, when Carl Sagan finally got permission to make the golden record, there was such a limited time they couldn't really think about how to go about doing it in a fair manner. So for music, if we asked the audience to pick what music you should send to another planet, or what music best represents us, that'd be an argument we'd have all night. So I think they just got some snob from the Rolling Stones to just pick his music because he knows music, apparently. But I think the interesting one was the greeting. So because they were so rushed for time, they just wanted as many different languages on the record as possible. So their process was basically, let's just find who do we know near us that speaks a language and ask them, what would you say to a sentient being if you had a couple of seconds to say something to them for the first time? So maybe that's a question for the audience. If say we were doing Voyager all over again and we just asked you, what's your greeting if you had to say something that could one day be heard by a sentient being out there? And that might seem like a tough challenge, but that's exactly what these people were asked around, I think it was Cornell University in 1977. If you try and do that without thinking about it, you get some good answers and some terrible answers. So some of the greetings, the English one isn't so bad. It's hello from the children of planet Earth, which is nice. The Greeks are a little bit more cryptic. Theirs is greetings to you, whoever you are. We come in friendship to those who are friends.
That's passive aggressive.
Yeah. I like when people go poetic. So the Persian one is hello to the residents of far skies, while the Polish one is welcome creatures from beyond the outer world. So yeah, if you want to give us a couple of suggestions, we might read out a couple of the good ones. What would your greeting be, Ariel? Putting you on the spot.
I'm tempted to send an animated GIF.
Yeah, some emoji or something. Yeah, just send something really annoying.
Yeah.
Okay.
Why not?
Why not? When you're looking at these things, especially seeing as you do it at the very top level at NASA, is there ever a time when you think, do you ever feel anxiety? Do you ever worry about what might happen in the future of space exploration? Do you have any concerns, or is it all just optimism and excitement?
No, it's unfortunately it's not all optimism. There's a lot of I wouldn't call it pessimism, but there's a lot of uncertainty that you have to deal with, and that's something that I've been increasingly put into a position where I'm having to straddle the excitement with like being any scientist, you get more evidence for things and you sort of have to recalibrate your expectations. And so one of the things through the national academies that sort of grounded me more was about learning that it's not guaranteed that there will be a human landing on Mars in my lifetime. Like, it can happen, but it's far from guaranteed. So many things have to come together. And so I think before going through the National Academy's Committee on Human Spaceflight, I think, like many people I know, I was thinking, yeah, there'll be a Mars landing in my lifetime. We went to the moon. Mars is a bit harder, but, we'll figure it out. Like, we're good. And as I've learned more about what it takes financially, politically, technologically, and how, we're not even at, the starting point for so many of those things, I sort of, it sunk in where I was like, oh, if I'm lucky, it'll probably happen, when I'm retirement age, but there's nothing guaranteeing that it will. It could easily happen after my lifetime. And I'm specifically talking about a human landing on Mars. Human orbiting Mars, I think, is something that's more likely that, we could see it happen. It's a lot less draining from all those different aspects. But a human landing on Mars is something where I've sort of been put in my place a little bit about just how difficult it is. The upside of that, the optimistic part of that, though, is because it's going to take sort of an unprecedented amount of international collaboration, an unprecedented amount of money, and all these different things. It's essentially an unprecedented endeavor that humanity has gone on, and because it's going to take so much to be able to accomplish it, the thing that does excite me about that is that if we are to make it happen, if we are to make a human land on Mars happen, it's going to take so many more people from so many different disciplines and so many more countries to make it happen, no matter who ends up leading the way on it. And that's really exciting, actually. It's sort of it's not guaranteed that it'll happen, but if it does, it's going to take a huge amount of us on a scale we just haven't seen before to make it successful. And that part excites me, and that part drives me forward about space exploration, is because the space industry, whether or not they realize it, and they are slowly coming around on this, they really need help from all different people around the world to make these larger accomplishments happen. And that's something that's thrilling, I guess.
Yeah, we live in hope. It does seem sometimes that Mars is as far away as it's always been. We should also give the opportunity to anyone in the audience who might not be using Twitter to raise a question if you like. We have a question here in the front row. I think we have, do we have a microphone? I can't see anything. Anya. Yeah. Anya has a microphone for you. Excellent. Thanks, Anya.
Hello. Can I? Yeah. Okay. My name is Giulio. I am an environmental biotechnologist, so I'm very biased toward biology in general. But anyway, once I saw a YouTube video about a shrimp who is capable of seeing different colors,
Yep.
and this shrimp and the speaker says how we cannot even imagine a different color that we cannot see. So my question is, how can you cope with the fact that our perception is actually forcing on us, on our thinking, a lot of boundaries that are possibly exactly those boundaries that are making it impossible to discover what is possibly very easy to discover. It's just we cannot see it. How can you go beyond our limits? How can you cope with our limits, and how approach this unsolvable question?
The simple answer is that you can't really cope. I mean, at a certain level, you can't. I think this gets fascinating when talking about the concept of multiverses, which I think Joe could talk about much better than I could. But with multiverses, it's something where a lot more and more math is pointing to the possibility that just the way I was talking about how we thought we were the only galaxy in the universe, that we might not be even the only universe in the universe. There might be multiverses, and the thing that's really difficult to cope with is that a lot of the research so far points to the fact that if there are multiverses, we quite well possibly might never be able to detect them. They might just never interact with our universe in a way that we can possibly perceive. And that's both due to physics and our own perception. And I think there are a lot of concepts like that in space exploration where all you can operate off of is what you know, and that can be incredibly frustrating. And so, I like the projects that do at least try to conceptualize, at least at a basic level of like, okay, we've got these building blocks that wouldn't produce life here on Earth, but if they produced some form of life like on Titan, how would that work? But I think at a certain level, I think similar to sort of the concept of the radio waves going out into the galaxy, and at a certain level they're indistinguishable from noise. I think our perception sort of goes that way too. Of at a certain level with space exploration, our perception can't it colors everything we do, and so I think it's important to bring it up as you have, as just a knowledge that that our perception of reality is definitely not the reality for many others. And you get into all sorts of weird space stuff that I don't even know a ton about, but is our universe a hologram, and all sorts of crazy, are we living in a simulation, and all this stuff that we can create philosophies or sort of look into. But at a certain level, you just can't cope. I don't know what to say. I don't know if you have any other answer to that.
I sure don't.
You're the astrophysicist. So.
Yeah, but you answered that way better than I would have.
Yeah.
Do we have another question? We have one up the back, and then another one in the middle, I think. Do you want to raise your hand again? Yeah, come on.
Hi. Just wondering how you would think about what the next step in exploring space would be in terms of the priorities. It's an exciting time at the moment, I suppose, with Pluto and Philae and Europa even starting. And how would you think about maybe what next, or what can we even achieve as such,
Yeah, I mean, so certainly I'm excited about the Europa mission that's getting more and more green lights throughout NASA. So the concept is to send a space probe to Europa, which is a moon of Jupiter, an icy moon that has a subsurface ocean on it that could possibly have life on it. The thing that's a little frustrating about that mission in its current state is that all of the payloads on it, all the sensors on it are set up to detect for the habitability of Europa, not to detect for life itself. So as someone who's impatient, it's a little bit frustrating, but as scientists or researchers would rightfully point out, we don't even know what to search for, and thus how do you build a payload for that? But I'm one of the impatient people, so I personally get, I just wish, we'd go like, well, let's just guess a few things and send it anyway, but of course when you're talking about billions of dollars and things of that nature, that's difficult. In terms of what's next, I'm personally someone who I just want to keep exploring as many new things as possible. I'm frustrated that Voyager 2 is the only spacecraft to have even done a flyby of Uranus and Neptune. And so we've just gotten these quick flybys of these planets that are the outermost planets in our solar system. And I think there's a lot more interesting information about them that we haven't gotten, and I wish they would get dedicated probes. Equally, as much as Europa is really awesome, the moon Enceladus, which is a tiny moon of Saturn, is really interesting for sending a probe to as well. Enceladus is an icy moon, and it's got a subsurface lake, I guess. And they've been able to detect plumes from Enceladus. And what's more exciting than Europa is with Enceladus, they actually know the makeup of those plumes and know that they have sort of organic compounds in them. I think I'm saying that correctly. And so a lot of people actually want to do a flyby mission of Enceladus and actually do a sample return where they would send a spacecraft to Enceladus, capture samples from the plumes that are coming there so that you could possibly actually detect life if it was there, and send it back. Again, from a research perspective, this is interesting, and some people are fighting for Enceladus over Europa because when looking at asteroid impacts and comet impacts and things of that nature, there's actually a lot of interaction between Jupiter and Earth. And so let's say we find life on Europa, the moon of Jupiter. Some scientists are concerned that actually it might not be different from life on Earth because there's enough asteroid sort of interaction between Jupiter and Earth that it could have, that through that interaction, the life that's on Europa could actually not be completely alien. It could be actually just, part of Earth, or vice versa, which is still really exciting, but not totally alien. Whereas with Enceladus, the interaction between Saturn and Earth, you have less of an interaction there between the asteroids and comets. And so if we were to detect life on Enceladus, we could say with a higher probability that it's completely alien, that evolved completely separate from Earth. And so stuff like that really fascinates me. I'm all for the Europa mission, but I do think there's some really fascinating stuff literally coming out of Enceladus, and I think there's better research done on it. Europa, I think, is still catching up now a little bit with all the information that we know about Enceladus already. So.
We have a real nice question from Alan here. Many astronauts describe experiencing the overview effect after the missions. Do you think we are all beginning to be affected weekly with images?
I hope so. That would be, that would make all the astronauts happy. It would certainly make me happy. I think a lot of people are looking into, how to get more of that effect through, virtual reality and everything. But I think a lot of astronauts have said, even if you get it pretty close in virtual reality, it just doesn't give you sort of the whole concept of it. And I think something that not all astronauts agree on, but I heard at least from a couple of astronauts, because I actually interviewed a number of astronauts for a book I'm doing that'll come out next year. And some astronauts explained to me that the overview effect, the concept of, we're on this tiny little planet and it's fragile and how small it is. They said it's not something you experience instantly. It's something that you experience after being up there for several days or even weeks. That it's something that you need more the factor of time as a thing. It's not just like getting the perspective of Earth and going like, oh, the atmosphere is fragile and now I get it all. That might be true for some people, but for others, it was really about, being able to point at your home and then go around the Earth, was it 90 minutes later, and point at your home again. And being able to sort of see, just going from, the U.S. to Europe and Africa to Asia in really rapid succession and seeing it over and over again, that's really what's generating the overview effect for them. It's really the concept of seeing Earth from that perspective, but also in the basis of time, and that's sort of what really brings in sort of that view. So that's interesting. As I said, like not all astronauts will say that, but some I interviewed said that that's actually the thing that does it, and that's why you couldn't fully really experience it with VR unless you were plugged in for like a week, I guess, which would not be advisable. Yeah, I think it's something where, some argue that you really do have to go into space to get that perspective. But I think at least being able to appreciate that perspective vicariously through astronauts is a great thing. And I think, even if we can get even a half of the way to understanding what it's like for astronauts, I think it does a lot of good in the world. So
make the world a better place.
Yeah.
We've got a comment from Joe saying astronauts, cosmonauts, and tachynauts are cool. We get a lot more return from money spent on robots, in my opinion. Also, robots are cool too. So comments are welcome as well. We've also got some suggestions of a greeting for another sentient being in 2015. Mike says, "Please don't shoot." That's a good one. We also have one space greeting, multi-universe YOLO, from our good friend David up the back again, which is very contemporary, but actually isn't a million miles away from, I guess, what the Burmese did in 1977, which was, "Are you well?" Not even with a question mark, it's more of a statement. So, there's different ways to greet sentient beings in different times. We are running out of time, so we're going to have to wrap up, I'm afraid, but if you would like to continue the conversation, or if we didn't get to answer a question you'd like, you can still use the Twitter handles and hashtags, and we'll continue the conversation. Thanks for being a lovely audience. We'd also thank Science Gallery for hosting us, the team here, Dave McKeown for everything, and Jesse up the back on tech. Most importantly, thanks to our guest, Ariel Waldman. And thank you and good night.